So now you've seen what is possible with an Inspec scanner, and right now I want to show you why especially the shining AutoScan Inspec is something really cool that is totally underestimated. If you have quality controls to do with a lot of parts, you will spend with a normal structured light scanner like a normal GOM scanner or as well a Transcan C or something similar. You will spend a lot of times catching all the angles of small details that is in a different angle that you are capturing right now. So you will have to on the turntable do a lot of rings. That means separate positions from the sensor itself to capture all the details. But of course, this is why I'm talking about it today here. It is possible to do it different, and I show you what is the really cool thing about the AutoScan Inspec. So if you are, let's say, realizing how to do it, you can do a full automatic scan with 3 clicks of this part, for example. And imagine if you have such a complex cast part with a lot of details and deep geometries, how much time you can save. If you have 300 of these pieces to be scanned in a normal way, I'm sure if you do that on a daily basis, in a few weeks you have amortized to buy that scanner, even in addition to a scanner that you already have. Because count the amount of hours that you will save and think about the money that it will cost you, or it is the wage of your worker that will do the job, or it's your own, let's say, possible time that you can save. But let's get right into that in this moment, and I show you why this scanner is so cool for that, because programming a scanner like this is really easy. So to do so, we are going to start a new project. I am going to create a new folder, or I'm switching the archives, and yes, we are going to create a folder, AutoScan. Sure. So we are in that setup mode. We are don't changing what is right now activated. We have a single object, no multiple object. What means there will be just one object as a scan result. That is the target. There will be not many of them. You can do that in the case you need it, but I see this is not an advantage here, and I don't need anything to be changed regarding removed curved edges. Yes. So let's start to scan, and I can here already pre-select some templates. I will show you to do this later on. You can manage it as well where it's saved and so on. First we're going to do the, let's call it programming, because it's so easy. It's not really something you should call programming. It's totally something that anybody can do with basic technical understanding. So let's get into that. So you can see right now the part itself in the preview on the left upper side, and I'm just going to fine adjust the camera. You can do that over auto adjustment as well. What is doing the brightness in the best way over the all visible area. So yes, if you want to do a 3-click scan on this part, you will need to define a scan area that is not showing the clamping device that you're using. So you don't have to cut manually anything off that part later on. That's why you have to avoid unneeded data. In this case, it means avoid seeing the clamping fixture in this case. To do so, I'm just going to do a preview, and I see here I can go down a little bit with the brightness, because it seems to be for me a little bit over bright. I just want to have slightly red areas, but not all red at all. I think this is something where we are fine, and I can just fine adjust here the visible area. So I'm just going to go slightly below the area where the clamping is shown, and the software will always respect that. It means all the area that's above will be scanned as well, translating, rotating, doesn't matter. He respects to blend out the clamping fixture. So for the first thing we are using some standard 16 paths. There is a default, I think it has 10 paths. This is what you will receive buying the scanner and connecting it. And I show you what's happening when you're scanning. This is quite something you might find another scanner for doing that, because there is an automated program and he will just do some standard scanning paths to do the object. This is something not so unusual. So what you already can see here on the screen itself, there is not visible that area for the clamping, so you don't have to delete it. Okay, I can just X that out. I just don't need that basic instruction. And I see, okay, this is another possibility to cut some plane, but we did that already before by narrowing that scanning space. And you can see right now this is your result. Just 10 views. It's not so perfect. So I have most of the possible areas, but I see that here is a lot of things missing in that deep pockets. If you are, let's say, manipulating the scan, just use the right mouse button for not change the position of that cutout plane. It will be more safe, and you can select the areas by your view that wasn't scanned properly, and you can right now add to the paths that you did that 10 standard path. You can select that view where you don't have enough visibility of the areas that you want, and you see right now, okay, to that standard program of rotation and scanning spots, you create a new one that's including that new green area that wasn't scanned by the pre-programmed path before. And you can just do that same for getting deeper in that areas here where you cannot see very well inside the pockets, and just add the scans like snapshots. And that's something totally easy that everybody can do actually, and you don't have to be a professor for that. And believe it or not, you're creating already your program. That means you're doing that one time. After that you can save it here with the disk button, and you can repeat it next time without doing anything. That means if you do the same part again, everything is optimized already for that view in that clamping position, and you just have to click at it. So that's why I say it's a 3-click scan in this case. But hold on. Okay, so we are just completing that, and as I told you, nothing really special. I just tried to get as much as possible of that areas covered in scanning to have the best possible result regarding the complete area scan of that top. And I'm just doing that step by step. Like always in programming, the first, let's say, optimization is taking you some time to finish it, and you can see as well below here there's some insight that it's not fully scanned. And if you are turning too much, this additional snapshot will be grayed out, because it's some view that is not possible by that let's say mechanics of the arm turning, and as well inclination is out of the range. So you have to go back until this button at a scan is activated again, and you can continue to scan. I recommend you highly to try to get the best out of what is possible in this view if you want to repeat that later on, because all that guarantees you that you have repeating the best possible result. So we are just one time, we're taking our time to program the best positions that you will need. And you see that already we have inside here, we have a really complete scan. and you're totally fine. So you see that you can do that, and just creating a program of optimized scan process is that complicated that you just right now click on that save button and you can say this is a test path. I'm going to delete it. It's just to show you what is happening. So you see this is the result that you would gain by optimizing. Let's do the rescan on the default process. That means just the standard views that you have selected before, to compare it once more, and you will see the difference. So you see here these areas are all missing, there is nothing really complete. So it's a really big difference. And right now we are going to do that again with our test path. Imagine here is all the areas in the deeper area not connected, that are, let's say, a bit deeper inside the part. I'm going to delete the history scans by rescan, and I have pre-selected my program that I did with you together in this moment to do it again, and you will see that this will repeat what we did before. So it's really a really intuitive way how you can program a scan if you have to do a lot of them. And imagine you have some let's say fabrication of small parts for watches or sunglasses, and you have to do a batch of quality control. How much time that will save you. You can even continue to, let's say, automate that kind of the jobs later on, no problem. Okay, we are not going to use that let's say view again of the beginner's advice. I just use a new laptop, that's why it's there, and this is just describing you what you can do. Okay, so this is what we did before. I continued to optimize that a little bit before the video and just show you how complete you can get. And then we will have just a few more paths than we had before. As you see right now, I was catching more of the inside geometry as much as possible. In this side here we are coming to that path that we optimized before, to, let's say, finish what is possible in this view. Okay, so we're just finished with this 44 views that he scanned. 40 views is let's say orientations in this case. And I'm just going to change the clamping of the part one time. You use, let's say, magnetic fixtures that are optimized for this use that we are showing here right now. So you are always, let's say, be faster even changing the positions. You don't have to screw that. It's just the standard equipment that comes with the scanner, and I think for explaining the principle it's totally fine. Flip scan is, let's say, add a new view as we spoke already. Right now I'm going to do the second orientation scan by an optimized path that I pre-programmed before I'm, let's say, recorded this scene, and you will see I just don't have to do anything to get optimized results. I'm catching all the inside geometry of the different areas that are a bit hard to reach. So it's the second click in the 3-click scan. And you can just click on a line And the program is really good in its auto alignment that you might know already from other shining products and software. That's totally fine. So you see that everything is good, so just accept on OK. I'm just doing the next position for scanning that part and finish it. And as well, I prepared another set of views before that are, let's say, taking in consideration the best way to scan it. And I'm going to flip the scan and do the next set of views to finish the part. Actually, this process is like a teach-in process that you might remember. That was some quite commonly used process in the past for teaching robots in simple, let's say, work processes. And that's actually very useful for, let's say, people in production lines or so to learn it fast, how to program and get good scan results in this case. Click on Align. Accept with OK. And we are ready to wrap the part, so we have all the needed views. We can leave it watertight, unwatertight, doesn't matter. If you make it unwatertight, you have open edges, small ones. In the case that you do it watertight, it will be closing, let's say, bigger gaps, but you will see it anyway. So and here we are, you can see the result, and you see that you have a really clean, nice scan, catching up all the small details that you need for having a complete part and doing a quality control. So that's absolutely perfect. You will be not exactly in a 3-click scan. It's a, let's say, first click, activate the first views, then the second click is, let's say, accept it and do the next set of views. Then it's the alignment click, then it's the last views, and it's the last alignment click plus the wrapping click. So it's 6 clicks if you do it manually, but it's possible to do that more automated even. I just wanted to show you how easy you will be able to scan such a complex part without having to always put it on a turntable, find a good position, readjust your scanner, or let's say have a special device for dislocating it on a big scanner. It's saving you a lot of time on, let's say, inspection on multiple parts, and especially when it comes to complex, let's say, parts where there is different views, what you have to respect. For example, if you have a thread or you have a lot of details, it's nearly impossible to catch all that small inside areas here in this quality like it is possible with the AutoScan Inspec. And that's why I really have to say, for the people who have to do quality jobs in smaller parts, that means where the main dimensions isn't over in 10 centimeters, it's absolutely the perfect choice. If you open up the software down there below, there is one option in the pull-down menu where you can activate inspection templates. I already created here one, but you can go into the settings and see if there is more or create new ones with the plus symbol. There is saved everything in parameters what you have here done, including the cutting outs that you did, even the manual ones. You have here a possibility as well to afterwards select different options. create a watertight model, or let's say rename it, whatever. But I'm going out of this and I'm just creating a new one that you see what is possible. The easiest way will be selecting a project that you already did, and I'm selecting here a scan of a filament sensor that I did, and I'm giving it a name that I will realize it again. It's a second sensor that I scanned, so sensor 2. And there will be automatically attracted all that, okay, I have to give it a name, the model naming method. That means if there is more models done, so this is lot 2, let's expect that there was produced more of them. And that's it, and there is preloaded everything from that first, let's say, project there. I do that with the filament sensor number 1 as an example, because I did it recently and it's still clamped in. And I start the scanning process, and he's already preloading all the scan paths that you learned how to define them before. And you can see he's scanning the part completely. That means there is as well pieces of the clamping devices that are scanned because I didn't define very well the cutout area, or at least I want to not lose the area that it's below or beside the clamping area, so I want to keep it, and I want to cut it out afterwards. But as you've seen, cutting out with the lasso tool is quite some work, and yeah, you don't have to do that. So after the finishing of the scan, it's processed, and you will see that this is all already cut out. And this was because it was saved like this in the project that we use as template. I made this cutout there for the first view, and here we are. And if you right now go to the folder where the object is stored, you have here with your pre-naming, you have the part numbers of what I scanned right now, and they will be saved there. And I think this is a really cool way to save more time even, and more possible automation, that it's not really difficult for as well simple workers to be learned. So that's it for today. Thank you for your attention. See you next time.